So as I mentioned, this is the second video on WSP 9.5 on the quadratic formula. On the first video, we covered the first half of solving these equations with the quadratic formula. And we did say that on some of them, it's easier to factor, split, and solve, but some of them are not factorable, and the quadratic formula will always work. Now, the second half of this worksheet, it says, state the value of the discriminant. And I hope we remember that the discriminant is b squared minus 4ac. b squared minus 4ac, okay? It's the value inside the square root. So when we do these, they're not asking us to solve, they're asking us to state the value of that b squared minus 4ac, the discriminant value, the value inside the square root. And then once you know what that discriminant is, you'll be able to determine how many real solutions you have. Now, you may have no solution, no real solution. You may have only one solution. You may have two solutions, right? Visually, that would imply that your parabola may not cross at all, right? Remember, the solutions are the x-intercepts. So this parabola doesn't touch the x-axis, so it has no real solutions. Or your parabola may just touch the x-axis at one location. Like, let's say that was the value of 1, 2, 3, 4, let's say 5. Then right there, your answer would be x equals 5 because the x-intercepts are the solutions, right? Or maybe your parabola actually crosses through at two locations, and that would be two answers, right? Maybe like x equals -2 and like -6, maybe. I don't know. So we're going to find out if it has one answer, two answers, or maybe no answers because it doesn't cross, but not by graphing. I mean, you could identify it by graphing and seeing if it touches or if it crosses at two locations or if it doesn't cross at all. But we're going to do this algebraically. And algebraically, we're going to be able to just find the discriminant. And if it's positive, then you're actually going to have two answers, two x-intercepts. If it's negative, you can't do the square root of a negative number. So that would be no solution because it's imaginary. And if it's 0, then you only get one answer. Maybe we should explain or actually look at the quadratic formula before beginning. And the discriminant is in red right here. Obviously, if this discriminant is negative, the square root of a negative is imaginary, you get no real answers, which means no actual x-intercepts. If your discriminant is 0, the square root of 0 is 0, and it doesn't matter if you add 0 or subtract 0, it's going to give you the same answer. Right? If you have 5 plus 0, it gives you 5. If you have 5 minus 0, it still gives you 5. So when your discriminant is 0, it only gives you one answer. If your discriminant is positive, then you could actually do the square root of any positive number. Even if it's not a perfect square number, you still get a decimal. And when you add that decimal and then go back and subtract that decimal, it really does give you two separate answers. So let's jump right in. Number 16. It is in standard form. It is set equal to 0, so it's ready to identify the a value, the b value, and the c value. It's ready to use the quadratic formula. The quadratic formula is this: x equals -b plus or minus square root of b squared minus 4ac divided by 2a. Whenever you use the quadratic formula, I recommend that you rewrite it with parentheses: -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And then you could easily plug in your b value of 8 right here and right there, the a value of 1, the a value is 1 in front of the x squared right there and down here, and the c value of 16 right there in that last parenthesis. Now, whenever you use the quadratic formula, I recommend to always begin with the discriminant. And what do we do inside the square root? You're going to begin with the 8 to the second power. 8 to the second power is 64. And then you could deal with the rest. You have a -4, but you're going to multiply that by 1. -4 times 1 is -4. And then -4 times a positive 16, that'll give you a -64. So you really have a -64. Okay, we got 64 minus 64. What is 64? Take away 64. It's 0, right? The answer is 0. That means that the discriminant is 0, okay? And that's actually what they're asking for in this section. Now, if you actually wanted to continue and actually solve this thing, you would now rewrite it as -8 plus or minus the square root of, and you're going to put a 0 in there, and then divided by 2 times 1 is 2. Now, we all know that the square root of 0 is still 0, so you might as well rewrite it as -8 plus or minus 0 divided by 2. And normally, the plus or minus produces two situations, which produces two answers. The -8 plus 0 divided by 2, and the -8 minus 0 divided by 2. But it doesn't matter if you add 0 or subtract 0, you only get one answer. It's the same answer. This is why when you calculate the discriminant and your discriminant is 0, you could just say only one real solution. That's what they're asking for in this section. They're asking, what is the discriminant? The discriminant is 0. And what does it mean that it's only one real solution? If I were to graph this parabola, it'll only cross the x-axis at one location, all right? If we kept going and actually solved this thing over here on the bottom, -8 plus 0 is -8. -8 divided by 2 is -4. That's one answer. And down here, you're going to get the same answer. -8 divided by 2 is still -4, okay? So if you were to graph it, it would be opening up with the pattern 1, 1, 2, 4, 3, 9. It would only touch the x-axis at the x-intercept of -4. So the vertex itself would be at 0, -4. Okay, so we're not asked to find the actual answers right here. There's only one answer, -4. Right here in this section, they're just saying, what is the discriminant? Do the math. We got 0, so the discriminant is 0. And then conclude how many real answers are you going to have? You only have one real answer. We actually went through and found that one real answer at -4. Let's move on to this next one, number 17. And again, we're going to focus in on the discriminant value, the b squared minus 4 times a times c, all right? So the b value is 3, that goes right there. The a value is 1, that goes right there. And the c value is 12, that goes right there. So the discriminant will be 3 squared, which is 9. 4 times 1 is 4 times 12 is 48. So you have 9 minus 48. Okay. So 9 minus 48, that's a negative number. That would be a negative 39. So your discriminant is negative 39. That's what they're asking for. And then after that, knowing that your discriminant is negative, how many real solutions are you going to have? Anybody? If your discriminant is negative, could you do, look, watch, what does that mean? That when I plug it into the quadratic formula, negative b, that's -3 plus or minus the square root, the discriminant's negative 39, divided by 2 times a, that's 2 times 1, which is 2. Obviously, the square root of a negative is imaginary, right? If you try to do this on the calculator, it won't work because it's imaginary, right? So if it's imaginary, that means it doesn't have real answers. If it doesn't have real answers, it doesn't have real solutions. It doesn't have real x-intercepts. This parabola will not cross the x-axis. So right here, once we know that the discriminant is a negative number, you could conclude that it has no real solutions. If you were to graph this on Desmos, it would be a parabola opening up with the pattern 1, 1, 2, 4, 3, 9 from the vertex, but that vertex will be above the x-axis, which means that it doesn't cross the x-axis. No real solutions. Now, if I asked you to solve this equation, you could stop right here and say no solution because it doesn't have real solutions. Now, in Algebra 2, you are going to be able to continue by moving this negative to the outside and saying -3 plus or minus I square root of 39 over 2, and you would actually get an imaginary answer, right? But in Algebra 1, if you ever have a negative inside the square root, we're just going to say no real solution. Okay, let's move on. Number 18, again, we're focusing in just on the discriminant value. But before anything, whether you're trying to graph this on Desmos or you're trying to solve it using the entire quadratic formula or just using the discriminant, before anything, what do you need to do? you need to take this equation and make sure that it's set equal to 0, okay? So right here it says equals -7. That's not good. You're gonna have to get rid of that -7 by doing the opposite, +7 +7. Then you could rewrite this equation, 2x squared plus 12x. You can't really add 7 to it, so you're just gonna put +7 at the very end equals 0. You need it to be equal to 0, whether you're graphing it or whether you're writing it, you're gonna use a quadratic formula. It has to be equal to 0 to be able to identify your A, your B, and your C. Okay, now that it's equal to 0, you could identify that, and we could jump right into the B squared minus 4AC and see if we get a positive number, a negative number, or 0, which will let us know if we have one answer, two answers, or no answers, okay? So the B value is 12, that goes right here. The A value is 2, that goes right here, and the C value is 7, that goes right here. And again, right now we're only working on the discriminant value, the value inside the square root. So when we do this math, 12 squared, that's 144, and then -4 times 2 is a -8, -8 times 7 is a -56. So 144 take away 56 equals 88. So our discriminant is 88. It's a positive 88, which means how many answers do we have? 1, 2, or none? 2. That's right. The 88 is positive, so you have 2 real solutions. Now, 88 is not the answer to the equation. There's going to be 2 answers, but if you actually wanted to find those 2 real answers, you would have to plug in your B value here, B value there. You have to do the whole thing, do the math, and it'll give you 2 real answers, okay? But on this second half of the worksheet, all they're asking for is to state the discriminant and how many solutions, how many real solutions you're going to have, okay? So number 19, let's set it equal to 0 by adding 30, rewriting it, 2x squared plus 15x plus 30 equals 0. Now you know that your A value is 2, your B value is 15, and your C value is 30. Let's say I did want to solve using the quadratic formula. I recommend rewriting it, but with parentheses. That way you could plug in your B value of 15 right here and here. 15. Plug in your A value of 2 right there, and your C value of 30 right there. Now, if you were doing the quadratic formula to find the actual answers, you're going to begin with the discriminant, and you're going to start by doing 15 squared. 15 squared is 15 times 15. With the calculator, to be on the safe side, is 225. So far we have 225. And then we go -4 times 2, that's -8. -8 times 30 is -240. So you really have 225 minus 240. And obviously the answer is going to be negative. That's actually a -15 to be precise. So on the second half, all they're asking for is what is the discriminant? The discriminant is 15. And I mean -15. And because it's negative, you could say that there's how many answers? 1, 2, or none? None. No real solutions. And why is that? Because if you were working it all out, you'd have a -15 plus or minus the square root of -15 divided by 4. And right here, this square root of a negative, that produces an imaginary value. So in Algebra 1, you could just stop right here and say no solution. But in Algebra 2, you're actually going to have to make that an I that comes out and write it as a complex number, an imaginary value. But right here, they're not even asking for the answers. They're just asking for the discriminant, the value inside the root, which is -15. Based that it's negative, you could say that there's no real solutions. What does that mean? That if you were to graph the original parabola 2x squared plus 15x plus 30, it would be opening up with the pattern not 1, 1, 2, 4, 3, 9, but 1, 2, 2, 8, 3, 18, and it would not cross the x-axis. The vertex would be above the x-axis. Because it does not have any real solutions, that means it has no real x-intercepts. Number 20. subtract 12x, subtract 12x, rewrite it, 4x squared minus 12x plus 9 equals 0. We now know our a value, our b value, and our c value. And we could focus in on the discriminant part since that's all they really want. The discriminant is b squared, which is negative 12. Let me do that in blue. Negative 12 squared minus 4 times a. We said a was 4 times c. We said c was 9. And of course, you do exponents first. 12 squared, a negative 12 times negative 12 is a positive 144. And then minus 4 times 4 is a minus 16. And minus 16 times 9 on a calculator is a minus 144. Okay, so 144, take away 144, that is 0. So our discriminant is 0, which means how many real answers are we going to have? How many times will it cross the x-axis? It'll only cross at one location. That means it only has one real solution. So one real solution. Now, if you actually wanted to find out what that one real answer is, you would have to use the entire quadratic formula. The discriminant ends up being 0. So the square root of 0 is 0. So when you add 0 or subtract 0, it gives you the same answer that you had before. But you'd have to do the whole thing to find that answer. So as I look at the rest of these, we have some decimals. I'm not going to give you any decimals on the test. Maybe one with fractions, right? Because you could easily deal with fractions when you have an equation, because you could do anything you want to an equation as long as you do it to the entire equation. So for example, if you didn't want this 3/4, this fraction, which is really saying 3 divided by 4, if you don't want the divided by 4, you could get rid of it by doing the opposite of dividing by 4. The opposite of dividing by 4 is multiplying by 4. And you can do whatever you want to an equation as long as you do it to the entire equation. So you could go times 4 here, which will cancel out, times 4 here, which will give you a negative 12, and times 4 here, which will give you a negative 16. So my new equation, after getting rid of the fraction, would be 3x squared minus 12x equals minus 16. Now, I still can't identify my a, my b, or my c yet because it's not set equal to 0. So you would have to add 16 first and add 16, rewriting it, and you'll get 3x squared minus 12x plus 16 equals 0. And now we could identify our a, our b, and our c. And now we could actually use the quadratic formula if we wanted to actually find the answers, okay? But all they really care about here is the discriminant, which will tell us how many real answers we actually get. So using the discriminant value b squared minus 4ac, we'll be able to find the discriminant value, the value that goes inside the square root if we were doing the whole thing. So b happens to be negative 12. That's the b value. So you put a negative 12 right in there. And the a value is 3, and the c value is 16. So when we do this math, negative 12 squared, that's 144. And then we have a minus 4 times 3, that's minus 12. Minus 12 times 16 on a calculator is 192, minus 192. So what we really have is 144 minus 192. And that is a negative 48. So our discriminant is negative 48. Knowing that this inside value is a negative, we know that this is imaginary, which means that it has no real solutions. The parabola will not cross the x-axis because it doesn't have real solutions. X-intercepts are the solutions. All right, so I guess that's enough for this second half of the worksheet. If you haven't completed the first half, please do so. Good luck.